the other half of that last section. So we were dealing with frequency distributions and qualitative data. We are now going to deal with a little different. We're going to construct a frequency distribution for quantitative data now. We're going to construct histograms. So histograms are a special kind of bar chart. And then we're going to talk about the shapes of distributions and then a couple other kinds of quantitative data displays, which are polygons and ogivs. So frequency distributions for quantitative data. So what's important here is that when we're dealing with quantitative data, we have numbers. So our variables that we're looking at are numbers. That means because there's numbers, there's going to be some sort of inherent order to it. So to summarize quantitative data, we use a frequency distribution just like those for qualitative data. However, since the data has, since these data have no natural categories, so before we had like natural categories, if you're looking at pets, you know, you had a rabbit category. This one is no natural category, so we make our own categories. So we divide everything into what we call classes. So what's important is that classes are intervals that all are going to have equal width. And that together, they should all cover all the values that are observed in the data set. We have this data set over here. So my class here is everything from 0 to 4. This is everything from 5 to 9. This is everything from 10 to 14. And this is everything from 15 to 19. Okay, so we talk about width right here. We'll get into that a little bit, but the class width, as you're noticing, is the difference between this value and this value right here. So if you find that difference is 5. And from here to here, that difference would also be 5. And from here to here, that difference would also be 5 again. We just want to make sure that these two numbers, that the difference between them, and then these two numbers, and then these two, always is going to stay 5. We're basically the same. Like it could be different numbers in different charts. Like here, between 9 and 4, that's also going to be 5. Between 14 and 9, that's also a distance of 5. And between 19 and 14, that's also a distance of 5. And like I'm saying, if you did a different kind of graph, you could actually take this data and redo it again, and you can have a class of like a distance of 4. Move it a little bit. When we make these classes, the classes are going to have what is called a lower limit, and they're going to be an upper limit. So lower limit is the smallest value that appears in that class, or can appear in that class. Sometimes we won't have one in our data set. So for the first one, we see that my lower limit is going to be 0, but my upper limit is 4. For the next class, my lower limit is 5, and my upper limit is 9. And then for the next class, lower limit 10, upper limit 14. And then this last class, lower limit 15, upper limit 19. Your class width is going to be the difference between two consecutive lower classes. So that's why they did this difference between 5 and 0. Because I could also look at these distances as well. It just has to be two consecutive lower class limits. It also could be two consecutive upper class limits, but we usually just talk about the lower class limits because there's a variety of ways that we make these classes. And it's usually easier just to always talk about lower class limits then. We're not going to touch all the different ways. I'm kind of simplifying this for us. Okay, so constructing a frequency distribution. So we are going to construct one, but these are the steps to follow. So the following are the general steps for constructing a frequency distribution. We always want to choose a class width. So it can vary. So sometimes it's how many classes we want or class width. But essentially, in the end, we just want to decide how long is that class going to be. We are choosing a lower class limit for the first class. So that lower class limit has to be either equal to your smallest data value or just below it. That limit is equal to your minimum value in data or less than it. What that means is, let's say I have some sort of data and my lowest value was 3. That means my lowest class either starts at 3 or can start at something before 3, like at 2 or at 1 or at 0. So you can change that lower class limit to something that's a little easier to deal with. We want to compute the lower limit for the second class by adding the class width. So let's say my class width was 5, and let's say my lowest class limit is 3. Then my other lower limit would start at 3, and the next one would have to be 8 because that's 5 more. The next one would have to be 13 because that's 5 more. The next one would have to be 18 because that's 5 more, and we'd keep going like that. The upper limit is the value that we hit just before the lower limit. So that can vary how we do it. So how your book is saying it is that just before I get to 8, I'm at 7.99. And that would be my upper limit. And then like here before I get the next class, the maximum I can get is, I think it's about 12.99. Like I said, these numbers can vary because I can choose to add extra 9s to it if I want to. There's always the possibility that if you like had a discrete data set, you might actually stop here instead. You might stop at 7. 7 is the largest value because it's my discrete data set, and 12 is my largest. So that number can vary a little bit depending on the data set that we have. After that, we're going to compute the lower limit of each remaining class. Stop when the largest data value is included in a class. Whenever that maximum value is finally included in one of our classes, we stop making classes. So we're going to count the number of observations in each class and construct a frequency distribution. So using this data here, I'll make a little distribution off to the side. Hopefully I get all the right numbers. In the next slide we will. I'm kind of going to be winging this a little bit here. Okay, so we want a class width of 1. And we're looking at the emissions for the emissions of 500, again, 65 vehicles. I don't know why I saw 500 there. 65 vehicles in units of grams of particles per gallon of gas. So we're just measuring the emissions. We are going to construct a frequency distribution with a class width of 1. So we're going to put our classes here. And the first thing we do is pick the lowest class limit. So if you go to your data, I think that is my smallest value. So we could start at 0.25, or we could just start kind of up here where you want to start that one. 0 would be a little easier to look at. Right. And since all my data goes to 2 decimal places, when we talk about lower upper limits, that's going to be part of that. We are going to say, we're not starting at 0, but 0.00. So my class width, if I add a class width to 1, I'm going to get my next class. I'm going to make a little adjustment here. I think I'm not going to be able to get everything in here. There's my class. So my first one starts with 0.00. If I add 1 to that, then my next class is going to be 1.00. And if I add 1 more to it, then my next class is 2.00. If I add it again, then my next class is 3.00. I'm not sure how far I have to go. I think 4. Add one more, 4.00. Now, like I said, we had 2 decimal places, do I do 2 decimal places here? So my smallest number before I get into 1.00 is going to be 0.99. Same thing here. This class starts at 1, and I have to end before we get to 2 because that's the next class. That one has to stop at 1.99. Or we could just keep adding 1 and get their next limit. If I add 1, the next class has to stop at 2.99. That's the upper limit. The next class upper limit is 3.99, and the next one is 4.99. The next thing we do is we do frequency. I'm going to shorthand it because I can't fit it all in here. So I'm going to try to find every number that is between 0.00 and 0.99. So we'd have 1, 2, 3, 4. Probably going to miss one here. There's a lot of numbers to look at. 4, 5, 6. So my frequency would be 6 here. Okay, let's get rid of both of them. They're gone. And then we would just do the same thing again. I need all numbers that are between 1.00 and 1.99. So we get 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, I think 26. And I just realized there's a couple of these I missed. There is 1 more there, 2, I know I saw another one, 3. So I think this is actually 9. But we can keep on going through like this. Next, we'd have to do my everything between 2 and 2.99. We've already counted that. We got 1, 2, 1, 2, 3, 4, 5, 6, 7, 8, 9. Like 9 of them. Everything between 3.00 and 3.99. Ooh, I need to go up further. We would have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And I just found another one here. So this is actually 10. Do all my 4s. I think we actually have 12 here. We'll go back and see here in a second. 4s. We got the 1. I missed that one too. So we just count the frequencies in each group. I just realized that we need to go up a little bit more because we had 5. So I need to go up 1 more here. So 5, and that'll end at 5.99, 6, and that'll end at 6.99. So I think there's 3 here. 1. I think there's 1 in this group and 2 in this group. That's essentially how we do it. It can be a little tedious and a lot of work. We're going to go compare here in a second. My marks up here. Like I said, this would be how we make our classes, just like I did. So smallest value was 0.25. So we stuck at 0.00 just because it just seems like an easier place to stop. Almost there. We had 1 off. This is 13. No, like I said, you just go through and you find what fits in that class, and then you put it in there as the frequency. When you do relative frequency, you're going to do the same thing like we did before. So just add up all those frequencies here. So if we add this up, some of my frequencies, so we'll end up having our 9 plus 26 plus 11 plus 13 plus 3 plus 1 plus 2. And we have a sum of 65. So all we did here is just 9 divided by 65. And we get roughly about 0.138. So just remember, you're just dividing all of these by that 65. So most of this, like I said, the really big difference between this and with qualitative data is qualitative data, they have those natural classes. But the whole concept of frequency and relative frequency are about the same. The only thing is you just have to construct those classes. That also means that I can make different classes of different lengths. They don't always have to be the same length. Like I could go back here and decide that I want to have class of a width instead. I have a class between 0.00 and it would end at, the next one would begin at 200 and this one would end at 1.99. And I would get a much frequency in there. One would be, I think we have 35 in that class. It doesn't always have to be the same. There isn't something that necessarily picks a class width for you. It's just sort of a decision on your own. And usually that's just based off looking at the data. So if you want to practice this, so pause and look at practice, but with the lengths of Carolina wolf spiders in millimeters are given. Want to construct a frequency, or relative frequency, just pick one in this case, using class width of 3. I'm going to go back in, I'm going to do both of them, but like I said, you just only need to do one. So it looks like here that my smallest spider, I believe, is going to be 17.5, and my largest spider is going to be 36.1. So you could start at 17 if you wanted to. Is my lower class. And then we only have like one decimal place, so I'd say 17.0. So we want a class with a 3, but I have to add 3 onto this to hit another next class. The next class should start at 20. If I add another 3, the next class should start at 23, then 26, then 29, then 32. That needs to make a little more room here. And then 35. And then I think we need one that's going to 35. Nope, I think we can stop there. The next part is the end of our class. So we have the, these are all my class lower limits. Now I need all my upper limits. So before I hit 20, I would end up maxing out at 19.9. Before I hit 23, I'd hit 22.9. Before I'd end up getting to 26, I'd be at 25.9. But notice that this is just a different 3 as well. So if I just keep adding 3 onto the upper limits, I'll give me all my upper limits. So this should be 28.9. This would be 31.9, then 34.9, then we would have 37.9. Okay, so the frequency, we need all the spiders that are between 17 and 19.9. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Looks like 13 are in here. If we look for all those between 20 and 22.9, then we have that one. Oops, we missed one here. There's 14 in this category. Like 15. Then we have to recount that one. So between 17 and 19.99, we actually have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Yep, 15 in there. Okay, so go back to 20 and 22.9. So if you go through here, you might be noticing that nothing seems to be between 20 and 22.99. We just say the frequency is 0. It's okay. Sometimes we have a category with no frequency in it. We still build these classes the same. It's just sometimes you have a class with nothing in it. We move on to 23.0 and 25.9. Well, we definitely have something there. We got 1. Is that it? I got 1. Well, there we go. 2, 3, 4, 5, 6, 7. And I think I found one more here, so I think this is actually up to 16 now. Between 26 and 28.9, go through and you just count again. So we definitely have 1 here, 2. Where's my class in? Not that one. 2, 3, I believe. Between 29 and 31.9. We got a 1, 2, 3, 4, 5, 6. And then between 32 and 37, or sorry, 32 and 34.9, we got 1, 2, 3, 4, 5, 6. I think 6 are in here, and then there's only 1 that fits in this category. I went back and double check. We actually had 2 down here because we should have a total of 30 data points. So we do have 30 at this point. So sum of frequencies is going to be 30. So you went to relative frequencies, you'd end up with 16 divided by 30. And this is going to round, I'll just round a few places to help fit in here. 0.53, we're doing a bunch of rounding here. Relative frequency is going to be 0. 0 divided by 30 is 0. There you go, something wasn't working right. 7 divided by 30 is going to be 0.23. 3 divided by 30 is going to be 0.1. 6 over 30 is 0.2. So we're going to note this one. And then 2 over 30 is going to be 0.07. And that's all my relative frequencies. So the histogram is essentially kind of like a bar chart. There's just some big difference here. But once a frequency or relative frequency distribution has been created, information can be put in a graphical form by constructing what we call a histogram. The histograms used for qualitative data are used for qualitative data, and they are related to bar graphs, which are used for qualitative data. The big difference you can see here is we notice that here the bars are right next to each other. So there's no gap between the bars, they're just flush to each other. We put those bars are all going to have, they're going to be the length of your class width, and your relative frequency or frequency is going to determine the height. If you go back to the emissions data that we had frequencies and relative frequencies. So what we want to make sure that we do is that we have this lined up between classes. You notice that we have 1, 2, 3, 4, 5, 6, 7, 8. So what we label down here are just our lower class limit. So we know that we're going to be between 0 and almost 1. So we write it from 0 to that 1 there. Okay. Then the height, so we're almost at 9. So we write the bar up to almost 9. So the next one is between 1 and almost 2. So it starts at 1 and the bar is going to extend to almost 2. And we go up to that relative frequency or that frequency of 26. Same thing between 2 and 2.99. So that's between 2 and 3. So we put a bar between 2 and 3. And we get up to about 11. 3.11 between 3.99. That's going to be a bar between 3 and 4. And that is going to move up and top off here at, what was I going to? 13. So you just keep doing that. So when you do the relative frequency distribution, the only thing that's going to change is just how you're going to, it's not the scaling, just the labeling. The graph should look exactly the same. So make sure that your data does stay in order here. You do not want to rearrange it because you're basing it off these class limits. So that is what gets, like I said, related down here. So we're doing that particle emission, which is what we were looking at, but what we label on here is just those class limits of those particle emissions. And part of what we like about these is they give us this overall idea of what's going on in our data. So you see it like goes up, comes down into a little bump here. What we see is that having cars with a lot of emissions, so like the 6s and the 7s, are not very common. They tend to be lower emissions. Number of classes can affect the shape of a histogram quite a bit. Too few classes will produce a histogram that lacks in detail. So we have a bunch of little classes here. So these are like class of width. I think they're a width of 0.10. They're just little tiny class widths. But we see we get tons and tons of groups. We get like 1, 2, 3, well, tons of groups. I think that's almost like 700 groups in there or something like that. If we did, or 70 groups. I think 71 groups. So this makes it a little harder to see because we can see all that bumping. We see this dip. Sometimes it's going to get this really jagged appearance. It's a little harder to read it than what we saw before. So just going backward. This is a little smoother looking than what we have here. If we have too few classes, then we kind of obscure detail. Here we have classes. So my going through this, so I know my class width is going to be 2. We end up with just 4 groups here. If you compare this to the other data, or the other way we did it, so here we see this little bump here, and we see emissions go up, but we see, we see a little bit more of a tail here. We see that our biggest bump is here. If you do it this way, then your biggest bump is right at the beginning, and it looks like it's slowly declining, when in fact it's actually going up a little bit, and then we go down. Because this is a general idea of what's going on with the data. Okay, let me get to